Hola amigos, this is PhiliBastian, and today we're going to talk to you about shader graphs!
So if you don't know what a shader is, it's basically a way of applying visual render effects to objects in your game. Previously, shaders were renowned for being tedious and hard to program, but Unity has recently released a visual node-based programming tool to make this easier. This is called shader graphs.
Look at this shader graph!
Here are some examples of what the shader graph can do. It can be applied to any material on any object, and the sky's the limit. Literally, it can also be used on a skybox. Let's jump into how they are made. First of all, you've got to open Unity, and when it's loaded up, click New for New Project. Make sure your version is 2018.1 or newer, as shader graph is a new feature to this version. We will name our project shader graph demo, and we will use 3D with extras just to be a little bit extra. You can use the others if you want. First of all, you've got to open up your package manager to download the shader graph package. Make sure it's the newest version and click install. Now you've got to install 2 more packages before you can use the shader graph. You'll have to install the render pipelines core and either the render pipelines lightweight or high definition. We will install the lightweight one. When you've successfully installed all packages required, you'll only have a few more steps to do. Right-click in your assets folder and create a new lightweight pipeline asset under rendering. Now that you've created that, go into your project settings and under graphics, drag your render pipeline into the slot that says scriptable render pipeline settings. That's all the setup you need. Now let's create our first shader graph by right-clicking in the asset folder, and under shader, select PBR graph or unlit graph. We will create a PBR graph, give it a name, and if you've done all the steps correctly, this is what it would look like. Now if we create an unlit shader, this is what it would look like.
Okay, so for our first shader graph, we're going to be making a happy little colorful toad. As you can see, we have our 3D model of our toad here. We go into our scene view. You can see him. He's very happy, surrounded by happy little clouds and a happy little place. So as you can see here, his current texture is just his default texture, which we have here. Now what we want to do is we're going to try and make a texture that blends in between each of these colorful toads and make this boy a very colorful and happy boy. Okay, so here you can see our final node that we'll be connecting all of our nodes to. Since this is a graphing environment, it's going to be quite physical. We're going to create nodes by right-clicking and going create node. And you can see all the different types here. You can either filter through here, or you can just type in what we're looking for. Since we're going to make a toad that's very colorful and changes color over time, we're going to need a time node. So as you can see here, this time node has many different properties that we can use. We're going to be using the time1 property. So now that we have one node, we're going to have our image imported into this. To do this, you click on this plus up here, and since we are importing an image, import texture 2D. And we're just going to call this toad texture. And the default texture we are going to be using is this texture which has 4 different toads in it. We're also going to be needing a vector, which is basically a number, and we're going to call this texture count. And since there's 4 textures in here, we're going to make that default 4. Now that we have imported our texture, you can right-click, create node, and type in toad texture. And you can see the properties show up there. Now you can either drag it into a slot, or you can just drag it on the ground to see what nodes it can be imported into. We're going to import it into a sample texture 2D, which basically allows this node graph to register this texture property as a texture in the node. So you can see our default texture here. Now, since we're going to be cycling through these things, we're going to need a new node called a flipbook node. This basically allows us to take in a single texture and convert each tile in the texture into its own image. So since this is a width of 1 and a height of 4, we're going to take our texture count property with the value of 4, and feed it into the height. Now, as you can see here, this is the output. We're going to drag that output into the UV slot here, and you can see as we change the tile, it changes which texture is being activated. Let's just keep that 0 at the moment. Now, since we're going to be using the time property, and we only want 4 seconds of time, let's add a modulus function using the texture count for the number 4 and time for the A, and you can see this cycles through the time. Black being 0, anything above 1 or equal to 1 will be white. So as you can see, this takes 4 seconds and it loops. Now, we don't want this sort of gradient curve, because then if we import that into a flipbook tile, you'll see we get this sliding effect, which we don't want. We just want to have the tiles change. So we're going to create a new node and go into math, round, and these are all the different functions that will round a number. Since we want to round it down, so if it's 0.1, we want to round it to 0, let's use the floor function. Import that into here, and as you can see, there's no smooth gradient. So now we can import that into the tile, and we can see that this texture just changes 1 by 1. If we move this tile into the albedo, which is the texture slot of this, you'll see our texture changes here. Now, we don't want this weird sphere angry toad. We want to see our happy toad. So in order to do that, right-click on here, pick Custom Mesh, and see we have our toad mesh here. So now we can see what this looks like on our baby boy toad.
Howdy, Baz from the future here. As you can see, we made some changes to the shader graph, basically to have a blend in between the colors. Unfortunately, due to the 10-minute scale, we can't show you that, but we've got it up here if anyone wants to try it out in the future.
What's this? It looks like Toad has been electrified, but he doesn't have any shader showing that he's been electrified, so this scene looks really dumb. Let's fix that. So, with the same thing, I open it up. However, we want to have some sort of like electricity pumping through him, so we're going to have 2 colors. The first color is going to be the outside color. So this will be like the lighting that Toad is being electrified by. And then we'll have a second one called the inside color. So as you can see, I've just set these colors to yellow and blue. Now the first thing that we're going to do is we're going to have some random like static appearing. So in order to do that, I'm going to create a new node, procedural noise. I'm going to use Voronoi, because we all know that William loves Voronoi. Now because we want the static to be changing a lot, the next thing that we're going to do is add a time element. The time element is going to go into the angle offset, and you can see this starts to move. However, we want to move it a lot faster, so we're going to multiply the time by, let's say, 10. Shader graph. And put it into the angle offset. As you can see, this moves around a lot faster. Let's maybe make it 20. Yeah, so that looks really cool. So the next thing that we're going to do is we're going to tie this to the screen position. So we're going to make a new screen position, get the out, and put it into the UV slot here. So then, when we move this and put it into the albedo slot, no matter where we move this around, it's not going to change where the position of the texture is.
Now the Voronoi node has 2 outputs, out and cells. Out is what you see here, while cells is whether or not the cell is filled, coloring it pure black and white with no gradient. So we're going to use that.
To make this a bit darker, we're going to subtract a bit from the cells. Let's say 0.8. And then we're going to times this by the color that we have. So let's get the inside color. Let's add it to this. This is going to result in a bit of a brighter color, but that's what I'm going for, so they'll look nice in the end. I like this, however, we haven't implemented the outside color. So let's do that now. Let's make a freshnel effect. I think that's how you pronounce it. Which basically lights out the outside of whatever object you have. And let's multiply that by the outside color to give this sort of halo effect. Let's pump this into the emission and see what that looks like. Cool beans. So, now that we've got that, let's make this a bit transparent. The first thing you need to do to make any of these shaders transparent is click on this, the cogwheel, and go to surface and change that to transparent. Now if you change the alpha, it's going to change the transparency. To control this a bit better and have it resemble what we've got in the shader, let's add these cells to the freshnel effect to get this sort of halo-y effect, and let's set that as the alpha. Doesn't that look cool? However, I think that this could be going a bit faster. So I'm going to multiply the time by maybe 50. That looks a lot better, I think. So let's save that. And let's apply it onto the toad. So if we go up here, we can go to electrified and select this. Now if we hit play, damn, that toad shook.
So in conclusion, I hope our video has helped you see that shaders can make any variation of toad. I guess you can also use it for other things than toad, but that would be weird, wouldn't it?